The chi-square, x2, distribution as a research tool and some of its most important parametric and non-parametric applications. The chi-square, chi superscript 2, distribution is a powerful tool in statistics, used by researchers to test hypotheses and analyze data in both parametric and non-parametric ways. Parametric methods rely on assumptions about the population distribution, example, normal distribution, while non-parametric methods are more flexible and do not require such assumptions. Although parametric tests are generally more efficient, non-parametric tests are invaluable when the population distribution is unknown or when no parametric alternative exists. The chi-square distribution is versatile, serving two main purposes. Parametric applications, it helps test claims about population variances or standard deviations. For example, it can determine if a population's variance equals a specific value or if the variances of multiple groups are equal. Non-parametric applications, it is widely used for analyzing categorical data, such as checking if observed frequencies match expected frequencies, goodness of fit tests, testing if two characteristics are independent, contingency tables, or determining if multiple samples come from the same population, homogeneity tests. Key properties of the chi-square distribution include its positive skew and dependence on degrees of freedom, DOF, which affect its shape and variability. Probabilities are calculated using chi-square tables, especially for smaller samples, while larger samples, n greater than or equal to 30, can use normal approximations for simplicity. Examples illustrate its practical use. Fairness of coins. A chi-square test can check if observed frequencies of coin toss outcomes match expected frequencies under fairness. Dice rolls. It can determine if a die is fair by comparing observed rolls to a uniform distribution. Independence tests, for instance, it can analyze whether income level influences university choice by examining observed versus expected enrollment patterns. Homogeneity tests, it assesses if different student groups, example, graduates, seniors, share similar opinions about teaching quality. Despite its advantages, non-parametric chi-square tests have limitations, such as requiring larger samples for reliable results and sometimes producing less precise conclusions. However, they remain essential when parametric assumptions cannot be met or when analyzing categorical data. In summary, the chi-square distribution is a fundamental statistical tool, bridging parametric and non-parametric analysis. Its applications range from testing variances to evaluating categorical data relationships, making it indispensable for researchers across fields. Software like Minitab simplifies these tests, though not all non-parametric methods are supported. Whether verifying assumptions or exploring data patterns, the chi-square distribution provides robust solutions for diverse research needs. Thank you for watching this video. Please subscribe to our channel BP International to watch more videos in the fields of science, technology and medicine.